Okay, so today's lesson we are looking at is inequalities and graphing. It's still part of our equations and inequalities unit. So, what is an inequality? So, this is going to it's going to be an equation, but instead of the equal sign, we're going to see greater than, less than, greater than or equal to, or less than or equal to signs. All right, so just a review of these symbols. If you have an equal sign with the slash through it, that means not equal. Here we have a less than. This would be the less than or equal to sign. This is a greater than, and then the greater than or equal to sign. Okay, so that little line underneath means or equal to. Okay, so just looking at some examples here, if we say x is less than 5, this is how it's shown as an inequality. So that basically means x can be any number that is less than 5, but it cannot be equal to 5. So these would be some examples. X can be equal to 4 because 4 is less than 5. X can be 2.1 because 2.1 is also less than 5. Here, a is greater than 0 is shown like this. A is greater than 0, that's how it's written as an inequality. So any number that's greater than 0. So here the examples, a can be 7, a can be 25 because both of them are greater than 0. Okay, here y is less than or equal to 2 is shown like this. This is the symbol for less than or equal to. 2 equal to 2. So these both would work, 0 or 1.5. But in this case, y can also be equal to 2 as well. And the last one, m is greater than or equal to 3 is shown like this. And again, anything that's greater than 3, so for example 17, but m can also be equal to 3, as shown with that symbol. All right, so next we're going to look at graphing inequality symbols. So when we have just a greater than or just a less than symbol, we have this open circle. And that means that the number, for example, if we go back to here, if it was less than 5, the number 5 is not included in the solutions. So therefore, an open circle is used for both greater than and less than. When we have a greater than or equal to symbol or a less than or equal to symbol, when we're graphing on a number line, we use this closed circle or a filled in circle like this. That means that the number is included as part of the solutions. So for example here, the 2, and in this example, the 3, they are included as part of the solutions. All right, so that is how we would represent it on a number line. All right, so next we have inequalities shown on a number line. So this first one, we have x is greater than 2. So x is greater than 2. And that means that the 2 is not included as part of the solution. So we use this open circle, and then we draw our arrow pointing to the right to show that the solutions are greater than 2. Here we have x is less than 5. So x is less than 5. So again, we used an open circle at 5, and the arrow is pointing to the left to show that all the solutions are less than 5. All right, let's look at the next two examples. So here we have a filled in circle, meaning that the value is included. So the first example, x is greater than or equal to 3. So at 3, you're going to put a filled in circle, color it in, and it's greater than or equal to 3, so we're going to point our arrow to the right. The next example, x is less than or equal to 6. So at 6, you're going to put a filled in circle, and then we're going to point our arrow to the left to show that it's all the values that are less than 6. All right, so here we have just some more examples of how to graph on a number line. So x is equal to -2. It should be here. That's where -2 is. So let me just correct that. Okay, so that is just placed at the wrong place. So I'm just going to cross that out. X is equal to -2 would be right there. Yes, it should be on the -2 to represent that x is equal to -2. So I've just crossed out this one here. It was placed on -3. That is wrong. Next, we have x is greater than or equal to -2. So it's a closed circle to show that -2 is included as part of the solution. And then everything is greater than the -2. So we have the arrow pointing to the right. Here we have x is less than or equal to -2. So again, we would use a filled in circle at -2, and then the arrow is pointing to the left. Here we have x is greater than -2, so we have an open circle, and then the arrow is pointing to the right, and then x is less than -2, so open circle, and then to the left. So next we're going to look at solving inequalities. So when we solve for inequalities, you're going to use the same methods that we use to solve equations. There's just 2 additional rules that we have to follow. So the first rule is if you multiply or divide by a negative number in the last step when solving an inequality, the less than and a greater than sign, they will reverse. So basically, if it was a less than sign, it's going to now become a greater than sign. If it was a greater than sign, it will become a less than sign. And that only happens if you multiply or divide by a negative number. The last rule we've already kind of talked about when we were looking at ratio type equations. But when we have a ratio type inequality, you're still multiplying top left by the bottom right, and you're going to place that onto the left side of the equation. And then you would multiply the top right with the bottom left and put that on the right side of the equation, of the inequality. So let's take a look at some examples here. So our first example, we have 3x plus 7 is less than 22. So we're going to solve this just like we have been type 2 equation. So the first thing we're going to do here is we're going to subtract 7 on both sides. That leaves me with 3x is less than 15. Next, we're going to divide by 3 on both sides, and that leaves me with x is less than 5. All right, so the last thing we have to do is graph that on our number line here. So we know x is less than 5, so we would use an open circle at 5, and it's less than 5, so we're just going to point our arrow to the left, like so. Now, in the textbook, it is shown in our modules, it's shown a little bit differently. Instead of an open circle, they use a curved line. So I'm just going to show that as well. All right, so when the value, the 5, is not included, they use, at 5, they use this curved line like that, and then the arrow would still point to the left. All right, so either the curved line like that at 5, or you would use the open circle like that to show that x is less than 5. So here we have another inequality to solve. We have 7x plus 6.5 is greater than or equal to 27.5. So our first step, it is a type 2 equation, so our first step is to subtract 6.5 on both sides. So that leaves me with 7x is greater than or equal to 21. And then we're dividing by 7. So again, we're just dividing by a positive number, so our symbol is just going to stay the same. So that becomes x is greater than or equal to 3. Okay, so the first method, so at 3, 1, 2, 3, I would have my filled in circle like so. And because it's greater than or equal to 3, I'm going to point my arrow to the right. All right, and then I'll show you the other method. I'm just going to delete that. The other method is at 3, you draw a straight line like this at 3, and then you point the arrow to the right. All right, so it's a straight line to show the value is included. So I'm just going to put the other method, which was the closed circle at 3, and it's filled in, and then point it to the right. All right, let's take a look at our third example. We have negative 4x minus 8 is less than 12. So like always, we're going to start by dealing with this number here. So we're going to add 8 to both sides. That leaves me with negative 4x is less than 20. And now here we are dividing by a negative number. We are dividing by negative 4. Dividing by negative 4. So here is that point where we have to reverse the sign because we are dividing by a negative number. So x here now becomes greater than negative 5. Okay, so it was a less than symbol, and now it became greater than because we divided by the negative number. All right, so now lastly is graphing. X is greater than negative 5. So we have our open circle, and it's greater than, so our arrow will point to the right. Okay, and the other method would be the curved line at negative 5, so like that, and you would point it to the right. Okay, so our next example here is a ratio type example. So this is where we multiply our top left by the bottom right. We do that first. So we're going to do 7x, multiply it with the 3, and we're going to place that on the left-hand side. So 7x times 3, that gives me 21x. And then we're going to do the same thing with the top right. We're going to multiply it with the bottom left. That's a negative 28 multiplied by 3, which gives me negative 84. All right, so we have 21x is less than or equal to negative 84. And then we just have to divide by 21 on both sides. That's a positive number, so our sign remains the same. and we end up with x is less than or equal to -4. All right, so graphing that at -4 on the two methods. The first method is drawing that straight line at -4, and everything is less than, so we would point it to the left. And the other method is showing that filled in circle like that and pointing to the left. This first example, so just like always when we're solving an equation, we want to bring the x over to the left side. So we're just going to subtract that 4x, subtract it on both sides. Okay, 5x minus 4x, that leaves me with 1x, or just x, minus 5 is greater than 4. And then I'm going to add 5 to both sides, and that gives me x is greater than 9. All right, so lastly would be to just draw the number line. So number line, and so I'm just going to show like 7, 8, 9, 10. We know it's greater than 9. The 9 is not included, so open circle at 9, and then the arrow points to the right. All right, so here we have 5x minus 3 is less than or equal to 7x plus 7. So what we always do is we move the x to the left side. So I'm going to subtract negative 7x. That's going to leave me with negative 2x minus 3 is less than or equal to 7. And then we're going to add 3 to both sides. And that leaves me with negative 2x is less than or equal to 10. And then here is where we are going to divide by a negative. We're dividing by negative 2. So here is where we have to reverse. I'm just going to make a note of that. Reverse the sign. Okay, so it becomes x is greater than or equal to negative 5. All right, and the last thing we would do is the number line. Oops. Oh, and when we do number lines, just make sure you do draw the arrows on the ends of a number line, because number lines do continue on forever in both directions. All right, so I'm just going to show negative 5, negative 4, there's a negative 6, and because negative 5 is included in the answer, I'm going to fill that in, and it is greater than, so I'm going to point my arrow to the right. Okay, so we're just going to do this last question, and we're just going to do it a little bit differently. We're just going to leave the x on the right-hand side this time, because some students, they just prefer not to use work with the negative x. So you can subtract 5x on both sides, and then you're left with negative 3 is less than or equal to 2x plus 7. And then we would subtract 7 on both sides, and that leaves me with a negative 10 is less than or equal to 2x. And then lastly, we're dividing by 2. and we end up with negative 5 is less than or equal to the x. Okay, but when you read this, if you read it from right to left, it's the same thing as what we got in our previous answer, which is x is greater than or equal to negative 5. All right, it depends on how you read it because now x is on the right hand side. So you would still read this as x is greater than or equal to negative 5. So now if I change the order, we would still read it like that. X is greater than or equal to negative 5. All right, so the only difference here was we put x on the right hand side of our equation. And then lastly would be our number line. Again, it is continuing on both sides. Okay, and then negative 5, negative 4, negative 6, and then we would have that filled in, and it's still pointing to the right.